with full enthusiasm. I hope that we'll do the last quarter. By the way, we have already floated the quiz 2. Kindly attempt the quiz 2. As you already know, all the quizzes are mandatory. The quiz will be open till Monday night. So please prepare first through all the previous syllabus I've already told you earlier, and then attempt it. But let's it's already 3:06, so let's not get into this right now. If there is any doubt, we'll talk about it later on. So let's get into the lecture today. So I welcome sir once again, that we have been discussing about for past 2 days, and this would be another day with Jaikumar sir. I welcome Jaikumar sir to
Yes, sir.
the
Yes, sir.
16th day, and I hand over you the session for today. Thank you, sir.
Thank you, sir. Thank you. So good afternoon to all. It's immense pleasure for me to meet you all once again in this series. So let's share my screen. Yeah. I hope my screen is visible to you.
Yes, sir.
Okay, fine. So today we're going to see about Penny which is a tool introduced by Xanadu software company. Actually, it is a quantum-based company. So in today's series, we're going to cover about this tool along with gates and how to prepare states, and we can touch upon quantum machine learning. So this tool is especially for quantum machine learning. So if you want to implement any quantum machine learning, you can use Penny. So some of the document in Penny are so easy and eye-catchy. You will enjoy it once you learn how to use this tool. And for a few topics, they gave comprehensive tutorials, okay, along with the code snippet. So this will help you, right? So what about this Penny? It is a software framework for differential quantum programming. So it is equivalent to Qiskit, but when compared to Qiskit, the code base is very limited. But interestingly, it offers some of the different hardware architecture support. Take an example of photonics. Okay, so using Penny, you can access the photonic-based quantum computer, or you can access AWS computer, or you can access ion trapped quantum computer, like different kind of hardware you can able to access through Penny. So much of supporters are there for Penny, including IBM Qiskit. Okay, so it is based upon Python library. So once you know Python, you can understand Qiskit, you can understand Penny. So Python will act like a key language. Okay, so personally I will like C, but if you want to say each and everyone from different domain, if they want to connect and collaborate, Python will act like a neutral language. So it is very easy for each and every domain people, not only for CS and IT. So this Penny will do compilation just in time. So that is one other big difference. And it is not about the programming language, it is about the platform, what they are providing. Okay, so you can simply compare Penny with TensorFlow and PyTorch. Okay, so those two majorly focused for classical computation, but Penny majorly focused on quantum computation. So with the help of this tool, what you can do variational quantum circuits by providing training data. Okay, so that is somewhat easy in this tool. So each and every tool have own advantage and disadvantage. Okay, so if you take this tool, especially developed for machine learning, especially for variational quantum circuits. So if you're interested. Okay, so how many hardware platform you're able to access through this Penny? You can access IBM Qiskit, Amazon Bracket, Google SIRP, IonQ, Rigetti, Crack, GPU simulation. So all these tools you're able to access, right? So once you develop any program in Qiskit, you're able to convert into Penny. So interoperability will be there. Okay, so much of APIs are available. You can use all this stuff. And the beauty about Penny, it is an open source. So most of the quantum tools will come under open source because they need people to collaborate, they need people to explore and contribute. Okay, So it is like win-win situation. So how to install Pennyline? You can install in multiple ways. Either you can install in your Windows, Linux, Mac. Okay, whatever the system already you have, you can install Pennyline very easily because it is based upon Python library. Okay. So once you install Pennyline, you can check simple coding like this. And you can access through VS Code. So Virtual Studio, if you have, you can install Pennyline through an extension manager. So that is also possible. So again, you can install Pennyline in your Jupyter notebook. So this is actually a simulator kind of thing. Suppose if you want to access the real hardware, you need to have the proper API from IBM Qiskit or whatever the vendor they are providing, you need to access through proper API and key tokens, right? So once you installed Pennyline in your Jupyter notebook, you can easily access just like a Python code. So I try to share this link with you. So go to this website and try to create an account in this website. So all of you see here, top right corner, sign in is there. So click sign in. So do sign in. So I have Gmail account. I already created account. So directly I will sign in. So once you logged in, you are able to see account settings, profile, all this stuff. So if you created any account in this Pennyline, put in the chat box, yes. So take some time, 2 or 3 minutes, try to complete. Okay, good. So please try to log in. So try to create account and put in chat box if you're able to create. So create sign in, look top right, sign in button is there. You can use your email, any email you can use. So try to register and log in. So after login, please put message in chat box. Okay, thank you, sir. Okay. So this is used for mainly 3 different categories. One is for quantum computing, one for integrating machine learning, and to do quantum chemistry. So this tool majorly focus on 3 aspects. One for quantum computing and integrating the already available classical machine learning towards quantum and to do quantum chemistry. So you can install Pennyline in multiple ways. I already shared how to install. So if you are not able to do, please follow this step. So if you have Python kernel, please install this. You can make a copy from GitHub. You can download the entire tool, right? So multiple ways you can install. So yesterday we discussed about Cube, right? Please try with Google Colab. So try with Google Colab. So open Google Colab. I try to give command one by one. Then check, are you able to do? So I'll try from my end. Maybe I use new file. Penny Lane. Look at the spelling in chat box. Penny Lane, not late. So the first command is executed. Able to fetch library from the server. So all of you able to run the first line, installing Penny Lane. Okay, great. Okay, fine. So next, you need to import downloaded library. So this is next two commands. So import Penny-Lane as KML, from Penny-Lane import NumPy as NP. So try to run. So once you completed, you can paste this code, writing a function. So in Python, the space and tabs are very, very important because your code will get decorated according to this. So if you miss any space, it will show error. Space and indentation are very important in Python. So I hope everybody able to do without any error these three steps, isn't it? Okay, good. So what they are doing, Penny Lane is integrated with HPC high performance computing, and they try to integrate with GPU. So they are collaborating with AWS and NVIDIA. So in future, you can do a hybrid computing using Penny. Okay, not only Penny, you can use tensor networks. So multiple ways to install. So according to the operating system and architecture, they gave all this code. Okay. So these are the quantum hardware devices where you can execute your code. So I will show what are the hardware platform they are providing. So they have quantum device partner with Xanadu, AWS, okay, Google, even IBM Quantum you can access through Penny, IonQ, Microsoft, Rigetti, Unitary Front, Quantum Inspire. Okay, so you can access with all these device partner. Okay, so what is the advantage of using this tool? You can use this tool for research, and you can compare performance, and you can have simulation and hardware execution. They have so much of demos, so plenty of demos are there in this tool, and you can use for education. Suppose if you are teaching quantum computing for your students, you can use this tool for teaching also. Suppose if your students are learning, they can use this tool like a Google Classroom. Okay, all of you are aware about Google Classroom or MS Team, where you can launch a course, you can provide material, and students able to follow. Please go to Google Colab. Please go to Google Colab. Do like this. So all these three codes are executed. So once you joined late in the session, what you can do, you can go to YouTube, you can watch what I previously covered. Okay, so this tool is supported and backed by Xanadu. So Xanadu is very good company in Canada. They are doing on-chip error-resistant photonic qubits. Okay, they are already doing research and development in photonic computing. Okay, so here you can see so much of simple examples given over here, which is integrated with Penny. So from Xanadu, you are able to link to Penny. From Penny website, you are able to link with Xanadu. So both are partners. Okay. So if you click anything, it will go back to Penny website. So this is what I mean. Okay. So once you have familiarity with Penny and if you have ample amount of knowledge, or if your students are able to do project over here, all these company they will hire. So Volkswagen, BMW, NVIDIA, okay, Google, IBM, Toyota. So all these very big industries already invested in quantum. They partner with Xanadu, right? So if you want to learn quantum, so pick only one tool, and keep on working in the one tool to master that. Okay, so before that you can explore all tools. So before picking one tool, you can explore all tools. Try to weight its positive and negative, and which one suits for you, for your need, you can pick that tool. Okay, so this you need to decide. And most of the very big university, they are using Xanadu. So take MIT, Harvard, University of Toronto. So all these big university are had tie up with Xanadu and Pinelli. They are using for their curriculum also. So in Xanadu, they are hiring some position. So if your students are interested, if you have well versed with this tool, you can apply for this post, and you can do research with Xanadu and Penny people. Okay, so before six years, I just started quantum journey for 5 or 6 months. Okay, automatically a person from Xanadu, they approached me and they asked me to join with them. Okay, that kind of very friendly people, and they are they are hunting the talented people across the globe. So this is one good opportunity. If you are really talented, they will pick you. Okay, they will approach you simply. Okay, right? So what you can do, you can go for right, sure. You can go for code book, or you can click learning. So after you log in, please do this. Yes, now only the menu is coming. Okay, so click resources, click code book, click resources, click code book. So like Quizkit, they have well-versed learning module. So this is very easy for you. Okay. So here you can see the fundamental codebook module. Okay, you can browse all module, right? So if you want to learn in a codebook map, they will guide you. So how to select your career path or learning path. So whatever you have interest, accordingly you can select your course. Okay. So I'll share this learning path. So each and every one of us need to start with introduction. So we need to start with introduction to quantum computing. Then slowly we can move to single qubit gate. Once you're familiar with single qubit gate, you can move to many qubit, multiple qubit. Okay. Then you can move to Hamiltonian time evolution. In subsequent classes, they are about to cover Hamiltonian time evolution. Okay. So once you completed, you can understand the entire Penny fundamentals. Right? Then you can move according to your desire. So you can move directly to applications, or you can move to algorithm. So based upon your interest. Okay. So until multiple qubits, you need to complete this 1, 7, and 4. Sorry, 0, 3, 7, and 4. So start with the first module, Introduction to Quantum Computing. So they will teach from basics. They will teach from basics, not only their tool, their command, they will teach from basics. So click all about qubits. Okay. So whenever you teach some course, you need to teach theory part, then you need to do some practical aspect, coding aspect, then you need to do some coding exercise, then you can provide some quiz. So this is how you need to conduct your course. Okay. So they beautifully organized everything in a single screen. So you can resize this screen in this way. Okay. Theory they gave. So for each and every topic, what is the learning objective? Like whatever we have syllabus in our institute, they have learning objectives. Okay. So each and every topic given with enough theory definitions or explanations, accompanied with these kind of images. Okay. So they starting to represent notation of qubit. So they compare from classical computer, and how we are representing binary data in classical computer. They gave with some voltage reference. So if something is beyond the threshold, we'll consider like 1. Below that threshold, we'll consider like 0. So this is how we are representing binary value, right? So same way they are starting all these notations, and they try to link with qubits. So the next one is mathematical representation of qubits. So in last 3 classes, we covered all this stuff. It will come under linear algebra, right? So from linear algebra, they will try to engage you with all this quantum terminology. So qubit state 0, because 0 is mapped to northern part of your qubit hemisphere. That is why the upper component is 1. So students, they are easily able to follow this content, and you also able to follow this content. Okay. So this is ket notation. So this is ket notation. You can see. And the reverse is Brown notation. The reverse is Brown notation. So this is, I will take pen. Forget to take. So this is column vector. This is column vector. This is row vector. Okay, in a single page, they have each and everything. So it is easy if you are teaching with the help of these two. And this is about inner product. Okay, if you want to take inner product between two quantum states, you need to multiply in this way. Okay, so this is between bra 0 and ket 1, and what you got 0. So if you do inner product, what it will produce, it will produce any relationship existing between those two vectors. Okay, so if 0 and 1, if you are taking inner product, it is orthogonal. Orthogonal means you will get 0. If you are taking with bra 0 and ket 0, you will get 1. So try to check by yourself. So try to compute bra 0 with ket 0 until the answer. Please put in the chat box. So try to calculate like this. What is the answer? So 1. Exactly. Exactly. So if you do with 1 and 1, you will get 1. So bra 1, also ket 1, you will get 1. Okay. You can compute norm, because if you want to do, if you want to take two state vector, and if you want to do calculation, you need to calculate norm between them. So all quantum states are normalized. All basis states of quantum qubit, it is a normalized form. It should follow normalized form. So that is why it is called orthonormal basis. State 0 and state 1 are called orthonormal basis, because they are orthogonal to each other, and norm should be 1. So likewise, you can explain superposition, you can explain measurement. Okay, so they gave small exercise, they gave solution also. So side by side, you can check how much you are able to understand, how much you are able to progress. So I am looking for coding part. Let's see where they gave coding part. Yeah. So the next exercise they gave coding part about quantum circuits. So I'll share this link with you. Please go on, land this page. So it is just like biscuit. Everything will start from 0. Then this is about control NOT gate followed by Hadamard gate. And this is double control NOT gate, which is 3 qubit gate. And this is rotational X. Okay, you can vary degree of your NOT gate. And here you can vary degree of your OR gate. Okay, rotational Y gate. So this is not just a rotational Y, which is a controlled rotational Y. Okay, so try to understand from this. So this is a generic NOT gate. This is a generic generic control NOT gate, C NOT gate. So this is rotational NOT gate. So R stands for rotation, X stands for NOT. So according to your angle, it will apply NOT operation. Okay, so it is parameterized. So Rx is parameterized. So when you give some input, according to that input, it will do some NOT operation. Okay, angle based upon the angle. Same way, so Ry is a rotational Y gate. It will do Y operation according to the given angle. Okay, so this will do rotational Y if there is any control from this qubit, this Y. If the quantum state is 1, then only it will do rotation. Then only it will do rotation. So all these things we covered in previous topic, qubit. So in penny lane also it will start from state 0. Gate operation, I think there is no coding part over here. Yes. So downside they gave coding part. Let's see if anything is there. So scroll down with that link, and here they started with coding part. I try to copy this code. Everything is copy. So indentation error. So we need to check what is the indentation. So I need to paste in this way. Let's see if any example code is there. No. So this is the problem with this code. Let's check. I try to paste one by one to avoid this mistake. So this is working. So slowly you need to copy paste without any indentation error. I will share in the chat box. So here you can check what is your level, right? So you need to maintain this level. So Google Colab is doing good thing. So we can maintain this level. Once you enter, it will come to next line. Then you can check this way. Here 0 and 1. Okay. So intentionally they gave this one. Yes, I gave. So no error. So I try to share this code. Because they gave code like copy paste, so students will do without any effort. So that is why they intentionally put this extra indentation. At least students will know, right, how to how Python code works and what are the mistakes will happen during indentation. Okay, so this is very good practice. Instead of giving right code, they will give some small twist over there. So students need to work on. Yeah, we will discuss how to draw a circuit. They gave the tutorial. So this is how it will generate. So what is the description of this code? They have two wires. So wire 0, wire 1 means you can implement two gates, and gate 3 which is connected with parameter 0 and wire 0. Okay, so it means you are implementing gate 3 on first qubit with some additional parameter. Okay, so this is single qubit operation. So next you can see, maybe I'll try to copy this code in Notepad so I can explain with line number. So this is one good tool. You can store Notepad++. So penylane.py. If you save like Python file, it will come under different colors. So it will be easy for you. Okay. So look at line number 1. We are importing penylane as a alias of QML. So it is the short form. So wherever we are representing QML, actually it is representing penylane library. Okay. So line number 3, what we are doing, we are defining a function. Maybe I'll use pin for this. Yeah. Now we can continue. So line number 3, what they are doing, we are doing a function definition. So this is called function definition. Okay. So in this function, what we are doing, we are defining some parameters. So this will act like input. We are giving input for our function. Okay. So sometimes you can say like input, you can say argument, or you can say parameter. So all are synonymous. So I am teaching for non-computer science people. Okay. So this is function definition. This is your function name. This is your function name in pink color. Okay. So within these brackets, whatever you are giving, it is like input. You are giving input for this function. Okay. So input or argument or parameter. So all these stuffs are same. Okay. So if you are defining any function in Python, you need to put this colon. You need to end with this colon. So this is about function definition. So this first line number 3 is called function definition. Okay. So here we are defining our function. So look at line number 5. We are starting from hash. So hash stands for comment. This hash stands for comment. Comment means it is human readable. Human readable. So we are putting this line for our understanding. So there is no meaning in the execution. So you can run this code with or without comment. It doesn't matter. Okay. During compilation, this code will not be considered. So remember this point. Whenever if you are putting hash, okay, whatever you are seeing this green color. So this is for user understanding. Okay, user understanding. Nothing to do with this code. Okay. So line number 6 is actual code. So line number 1, 3, 6, 7 are actual codes. So line number 5 for additional input. If you are reading your file, you need to understand what it is doing. Okay. Most of the time, software developers or coders not only writing for themselves, they are writing for others also. Okay, suppose the project is evolving, keep on evolving, you will get transferred, additional people will add it to that project, or projects are handover. During that time, you need to have readability. Okay, this is for understanding about that code or something like that. So this is always best practice. Whatever you do, if you are a programmer, if you are a coder, if you are a creator of particular code, you need to explain that code. So it is easy for others to understand your code, how it is working. Okay, don't worry about number of lines. You can write so much of paragraph or detail whenever it is necessary. So line number 6, what we are doing? Line number 6, what we are doing? Okay, we are calling QML. So this is related to penny lane and we are associating with dot. So here dot act like association. Okay, so what type of association? It is able to create a gate 1 over your penny lane circuit. Okay, so this is about your function. You try to create a quantum gate. Imagine it could be X, it could be R, it could be Y, it could be anything. Okay, so gate is generic in sense. So in QuizKit, we are exactly defining X gate, Y gate, or control node. But here we never represented what type of gate it is. We are representing general gate. So remember this. So gate 1 is in the sense of generic gate. It could be neutral. Okay. Once you specify, your gate will be get determined. Right. So we are creating two gates. One is wire 0, one in the wire 1. So imagine in this way. So wire 0 is Q0. Okay. So wire 1 is Q1. Okay. You implemented gate 1 and you implemented gate 2. So this is the meaning of line number 6 and line number 7. Okay. So look at line number 9. We are creating a quantum gate with some input parameter. Okay, we are defining some parameter. What type of parameter? Line number 10 defines gate 3 and parameter 0 and wire 0. It means you try to create one more gate G3 over here because wire number 0, okay, with parameters equal params equal to 0. So this is how you need to understand this code. All right. So next what we are doing, line number 12, we are defining 2 qubit operation with no input parameter on wire 0 and wire 1. So what I do, I try to maybe possible. I need to redraw all the circuit. I will check. Okay, I'll draw that circuit. Q0, we implemented gate 1. Okay, so Q1, we implemented gate 2. Okay, so in Q0, we again implemented gate 3 But what is special over here? Parameter equal to 0. So this is what we did over here, right? So line number 13, what we are doing, we try to implement 2-qubit gate. So what is 2-qubit gate? It could be control knot, it could be swap gate, it could be any quantum gate which will related to q qubits. Okay. So between wires 0, 1. So what we are doing, we are implementing a 2-qubit gate. So imagine this is gate 4. So between 0 and 1. And line number 16, notice what we are doing. We are creating one more 2-qubit gate with parameter 1 between wire 0, 1. So it means again you are creating 2-qubit gate. So imagine this is gate 5 between 0, 1. And what we are doing, we are giving parameter 1. Okay. So last line number 19. So your quantum circuit going to measure between wire 0, 1. So this will happen. You are doing measurement over here. So you are measuring to classical bit. So classical bit could be C1 and C2. So this is the basic understanding about the penny lane code. So we have 2 qubits. We have 2 qubits, Q0, Q1. We implemented gate 1 in Q0, gate 2 in Q1. We implemented gate 3 in Q0 along with parameter equal to 0. Okay. Then we implemented 2 qubit gate 4 between 0, 1. Then we implemented one 2 qubit gate 0, 1 along with the parameter. So what you can take from this, you can create a general gate or you can give some parameter for the gate. Okay. So finally you can do measurement from both qubits. Okay. So this is how they are defining this circuit. Are you able to run? Are you able to execute this code? So I don't have any error while running this. Executed. So put in the chat box if you're able to run. Okay. Next, we're going to design a particular circuit. So the previous circuit doesn't have Hadamard control knot. It is just about single qubit gate, double qubit gate. Okay. Sometimes without parameter and with parameter. But here, maybe due to indentation error, because code is very, very simple. Very, very simple. Okay. So here we need to implement Hadamard gate followed by control knot. We can observe, wait for some time. We are going very slowly. So every topic will be covered. Okay. So Hadamard gate followed by control knot followed by control Z gate with some parameter. So you understand how to create a generic gate, how to create a particular gate or 2-qubit gate, how to do measurement. Okay. So for this, we want to write a particular program in this way. So I try to run this code first. Yeah, code is working. I will share this code with you. Please wait for some time. They are defining, right? They will tell how to print your circuit. So this is about function. Okay, this function will create some circuit. Then we can visualize that circuit. So look at this code. So much. Okay. So look at this code. So line number one, what we are doing, we are defining function. So my first circuit is your function name, and we are giving input for this function, which is called theta. So this is one angle. Okay. So line number three, what we are doing, we are creating a Hadamard gate. Okay. For your QML penny lane circuit. Okay. Where we are implementing wires equal to 0. It means first qubit. Okay. The line number four, what we are doing, we are implementing a control NOT gate, C NOT gate, between which qubit and which qubit, qubit 0 and qubit 1. So line number 5, what we are doing, we are implementing a rotational Z gate. For that, we are passing some input parameter. So what is the angle? Theta. So where you got this theta? From the function input argument. So whatever you are passing for this function, okay, that input is passed for this RZ gate, like an input angle. And where we are implementing this RZ gate in qubit 0. Okay. So what this circuit will do, it will get execute and it will return results. So line number 7 will give probability from between wires 0, 1. So this is called measurement. Are you able to get the idea? Whether it is running, everybody able to get without any error. Okay. So this is how you will get output. Okay. To execute this circuit, to view this circuit, what you need to do, you need to access a real device. So how you can access a real device? You need to mention device name. Then you need to mention how many number of qubits you are about to use. Okay. So I'll open this image. Yes. Okay. So here what we are doing, we are implementing on Hadamard gate and we try to do measurement, and we are implementing one angle gate, phase gate, and we try to measure. Okay. For that we need to write function. Okay. So according to the function, it will result probability. So where we going to execute this quantum function? In the selected device. Okay. So Q node is nothing but it comprises quantum function along with quantum device. In the case of penny lane. So in penny lane, if you want to access any device, what you're supposed to do? You need to create a quantum node called Q node. Okay. Q node contains two parts. One is quantum function and one is quantum device. So to do this, what we are doing, we try to run this code. So a single apostles they give, default is not defined. Yes, see. So if they are giving code, they are giving little bit wrong. So user can do some basic research. They can understand. Very good strategy. So try this code. So if you are giving any code for your students, give little bit twisted code. Okay, it will make some error. Okay, students can do some homework. They able to solve. So don't give perfect working code. So if you are giving default qubit means it will do simulation because there is no device name. So that is the logic. Are you able to execute? All of you able to execute? Okay, good. If you are not able to execute, I will share this code with you. So you can do on your own. So it is not that much hard part. So we completed the first module. Already the link is shared. You just go to this link, follow step-by-step procedure. So very easy. So if any errors are coming, little bit. So something related to indentation, something related to single quote. Okay. Very easy. So the next thing is about unitary matrix. Suppose if you want to do any operation, you need to know what are the operations you can do over your qubit. Okay. So what are the operations you can do? Whatever you do, it will change quantum state. Okay. So in case of identity, it will retain. So even though if you are applying identity, it will go from quantum state to psi dash. Okay, new state. So here you can apply unitary parameterization. Suppose if you are doing any rotations, so it will do some changes. Okay. So all this will happen through phase. Okay. So we completed basics. We are moving to X gate. I'll share this link with you. So just like this gate, we start with NOT gate and Hadamard gate in penny lane. So you can do resize. You can do resize window over here. So what is the logic of X gate? So if you are applying X gate over X, it will return 1. If you are applying X gate over 1, it will go to stage 0. Okay. So X gate have matrix in this way. So this is opposite to diagonal, anti-diagonal matrix. So which is a NOT gate, or you can say bit flip, or you can say state flip. Okay. So you can represent in two ways. Either you can put X or you can put like crossfire. Okay, in Qiskit you notice this symbol. So this represents X gate or NOT gate. So this is Pauli X. Same way I can say Pauli Y, Pauli Z. Okay. The next important gate is called Hadamard gate. As we know, Hadamard gate will create equal superposition. So this is the matrix form. So Hadamard H equal to 1 over root 2, and you have all components 1, 1, 1, minus 1. So here you can divide this Hadamard gate into two ways. Okay, so 1 over root 2, 1, 1, which represents positive state. Sorry about that. Which represents positive state. Okay, so if you divide this part and if you are representing separately, so 1 minus 1, which represents minus state. So this is the combination of positive and negative state. Mathematical to combination of positive state and negative state. I hope everybody able to remember. All right. So if you apply Hadamard from state 0, where it will go? It will go to negative state. If you apply Hadamard from state 1, it will go to negative. Sorry, this go to positive, this go to negative state. So if you are combining this, okay, Hadamard will be described with this both combination. So this is what I explained. So Hadamard applied over 0, so it will go to positive state. So how will you express positive state? In this way. Okay, if you applied Hadamard from state 1, it will go to negative state. Now these are equal. Are you able to guess? So these are equal. So you can see coding exercise. Okay, I forgot this. So you can do coding exercise. I try to copy this code, share in the group. If you are able to complete it, let me know. So try to execute this code. Try to produce the expected answer. So what could be your code? What could be your answer? Probably yes, whether they are defining any code. I will try to check. No coding part. Okay. So this is the matrix form of Hadamard Git. Are you able to get the idea? So this U is matrix form of Hadamard Git. So are you able to do? So once you completed, you can go to the next module. So we completed single qubit gate. So go for multiple qubit gate. So in multiple qubit, you can imagine control node, swap gate. So all these gate will come. To understand multi-qubit gate, you need to understand the tensor product. So I will explain this. So this is about tensor product. Okay, suppose if you have two column vector, okay, if you are doing tensor product between two column vector, so A component A is multiplied with component C as well as component D, as well as B multiplied with component C and component D. Okay, so finally you will get four rows. Okay, this is different from matrix multiplication. Okay, here the dimension will get increase each and every time. Dimension will get increase. Okay, so this is for one column vector and one more column vector. A single qubit code, that is over. That's all. So you can represent qubit in different ways. Okay, you can implement X, you can implement NOT, you can implement Hadamard. So single qubit gates are very few and limited. So here you can do 2 cross 2 tensor product from 2 cross 2. I'm looking for observation where they mention. Wait a second. So all these courses, let's see in fundamentals what we left. Yeah, measurement in quantum operation. Exactly what I'm looking for. So we created single qubit, we created double qubit. Okay, then we'll see how to measure those circuits. Yeah, first time we got output. So here only they are focusing on output. So if you run this code, you will get error. I try to put line one by one. See, if they are giving some copy, they're giving some copy tool, it will be easy for us. So purposefully they are not giving. So I'll give some dots. Try to copy from downside, down this line. So try to paste line one by one. Okay. Otherwise you'll get error. I'm also copy paste line one by one. Again, tricky part, you need to give indentation. Okay. Are you able to get output like this? Please let me know. So if you are not able to do, give this indentation. Sorry about that. Yes, just now it is coming. Okay, from the website we are directly copying. It is not coming from Google Colab. It is coming from indentation. Very good. All of you able to get this output? Am I audible? Are you able to follow? Okay. Just run this line. Otherwise, you need to install previous packages. Let's see what is the error. So try to install in Google Colab. If you already installed, you will get output. If you are not installed Penny, try to install Penny with this command. So install Penny first, then import these two library and packages, then run this following this code. Definitely all of you will get output. Code is very easy. All of you got output? Okay, okay. I try to explain this code. So using multiple tools, multiple window, always time consuming. Anyhow, we need to manage. Yes. Okay. So look at line number 1. What we are doing, we are creating a device. Okay. So here we are giving default qubit, which is nothing but simulator. So there is no device. There is no device, no physical device. You can say no physical device. So in future, you can select physical device. Okay. For understanding purpose, we are running simulation. Okay. So what is the number of wires equal to 1? It represents number of qubits. It represents number of qubits. QML, sir. QML, not QM1. So this is L. This is L. Okay. So shots means how many number of time you are executing. How many number of times you are doing simulations. So if you are getting that error, what you're supposed to do, you need to install PennyLane first. You need to install PennyLane first. So that is why I told, suppose if you are attending any workshop, attend from first or go back to so try to install this line, sir. Then you retry. Otherwise, what you can do, you can restart your session. So go to Google Colab, try to restart your session. That could be a problem. Okay, you go to runtime, okay, restart session, then execute all this code. Definitely you'll get output. Okay, so here if you're giving 10, it will execute for 10 times. If you're giving 100, it will run for 100 times. Whatever your device you mentioned, okay, you try to create a quantum node. Okay, already we discussed what is the meaning of Q node. Number of wires equal to 1 qubit, right? 1 qubit. So here we are mentioning number of qubits. Here we are mentioning which qubit to implement. So it is starting from array Q0. So that is why we are mentioning 0 over here. Are you able to understand? Okay, this is number of qubits. Okay, very good, very good. Okay. So what we are doing, we are creating a quantum node. Quantum node comprises of quantum simulation code, function code, along with your physical device. So it comprises both. Okay. So line number 4, what we are doing, we are defining a function. What is the function? Circuit is your function. So in this circuit, what you are doing, you are implementing a Hadamard gate. Where you are implementing in qubit 0. So this is in this way. Q0, what you are doing, you are implementing Hadamard gate. So what this Hadamard gate will do, this Hadamard gate will produce 0 sometimes. Okay, this Hadamard gate will produce 1 sometimes. So it will produce random value. Okay, so sometimes 0, and sometimes 1. Okay, so in which proportion it will produce? 50-50 percentage. Okay, so what you are doing in line number 6, Okay, you are taking sample out of your circuit. Okay, so how many samples you are taking? You are taking 10 samples. So this is what it means. So each and every time you'll get randomly value 0 and value 1. So this is a simple example for running your Hadamard gate. Okay, so whenever if you are doing any coding part, try to change value and try to observe how your circuit behaves. So this is the logic. What I'm doing, I'm making shots equal to 1. I'm running only one time. So what I got value as 0. So I will zoom for your convenience. Okay, I changed shots equal to 1. Here, if I'm changing shots equal to 5, I am executing for 5 times. Okay, out of 5 times, it produce 4 times 0. So you may ask question. Okay, so it will produce 0 for 50% of time. It will produce 1 for 50% of time. For smaller number, you cannot differentiate this because it will happen totally random way. Okay, to ensure this, if you are executing for 10 times, this error will get reduced. Now we can see variation between zeros and ones. So how many ones are there? 4 ones. How many zeros are there? 5 zeros. So little difference will be there, not exactly 50-50, maybe 49 and 51. All right. If you are able to execute for 100 times, you will get more nearer value between 50-50. So try to change this value and try to execute this code. So this code will generate a random binary sequence. So here we are doing simulation. Actually, we can select quantum hardware and we are able to produce a quantum random generated number. A random generated number based upon quantum device. You can say in this way also. So if you are doing sample means it will take sample from Q0. All of you able to follow? Still you are getting any error? Yeah, if you are coming late, please watch YouTube video which is already telecasted. You can go and watch. Otherwise, the topic is very simple. I'll share this link with you. I'll share this link with you. So find out yourself where this code is located. That is what I told. If it is not defined, restart your session. Go and check, restart your session. After installation, what you can do, go to runtime. Okay, restart session, then run. Okay, these are very simple codings, so don't worry about this. Already shared link. Please go through this and check where this code available. So don't worry about the execution. If you are not able to follow, after some point of time, watch this video, then you can execute. So what the lesson I learned, copy this code, paste in your Google Code app, then paste in chat box. This is about simulation. Okay, this is about simulation. We cannot guarantee, but if you are selecting real quantum devices, you will get true random number. Okay. So try to execute this code. Sorry about it, will generate sometimes. Yeah. Sometimes it will paste in formatted way. Sometimes it is not pasted in formatted way. Okay. Anyway. So how to count number of times you got the output? By using QML counts. Are you able to get for 1,000 times? Are you able to get for 1,000 times? So each time it varies. Each time it varies. So add up 503 and 497, you'll get 1,000. Are you able to observe? Each time if you run this code, the result will vary. Okay. So this is how you can recheck how many times you got value 0, how many times you got value 1. Fine. So if you want to know probability, okay, you can use probability function, which will happen over computational basis. So I'll share this code. So executing this way. So it is not like normal Python editor. We need to give explicitly. So I try to define this code for you. Okay, so look at line number 1. What we are doing, we are defining a device which is a simulator. Okay, simulator contains 2 qubits. Okay, So what we are doing, we are creating a simple circuit. So line number 4 is function definition, and we are defining Pauli X. Pauli X is nothing but NOT gate. Okay. So where we are implementing NOT gate in quantum bit 1. Okay. So it will return the number of probability for entire circuit. So there are two qubits, Q0, Q1. Okay. So where we are implementing Pauli X in Q1. So this is not gate. Okay. So how many outputs you'll get? You'll get 0, 0. Okay. 0, 1, 1, 0, 1, 1. If you have two qubits, you'll get all these possibility. Okay. But here you are starting from 0. You are starting from 0. Here you'll get state 1. Here you'll get state 0. Okay. If you do measurement, what you'll get? You'll get 0, 1. So you'll get 0, 1 over here. Are you able to get the idea? So remaining you'll get 0 for this. So only for this you'll get 1. Okay. So what I do, I try to change this. Instead of 1, if I give 0, what will be the output? So I'll put in the chat box. I changed qubit. Okay. Now you try to print this and tell me what you got. What is the output you got? So instead of 1, I changed 0. I implemented Pauli X on 0. One zero. Very good, sir. 1, 0. So we have two qubits, right? Q0, Q1. Okay. So all these qubits starting from 0 state, right? We implemented NOT gate over here. Here you'll get 1. Here you always get 0. Okay. So 2 qubit means 0, 0, 0, 1, 1, 0, 1, 1. Okay. So you will have state combination. Sorry. One zero. So for this you got 1. For remaining you will get 0. So this is the relationship between this output. So whatever you did in Qiskit, so you can implement all these gate in penny lane also. So which is very, very easy for you. So once you understand Qiskit, learning penny lane is quite easy. Okay. Okay. So I will share this code. You execute and tell me What is the idea about this circuit? Can anybody explain this circuit? What it is resulting? I try to zoom. Can anybody explain this circuit? Put in the chat box. One Pauli gate, exactly, sir. One Pauli gate we are implementing. Where we are implementing? So recall the previous circuit. Recall the previous circuit. So we created a quantum device with 2 quantum bits, right? Here we are implementing Pauli gate on second qubit. So put 0, Pauli gate on first qubit. Okay, if you put 1, Pauli gate on second qubit. So that is why if you execute this, and you're looking for values for wire 0, it means you are measuring only first qubit. I try to explain. So you have 2 qubit device. Okay. So Q0, Q1. Okay. So here what we are doing in line number 4, we are implementing Pauli X on qubit 1. So it means you are implementing Pauli X over here. Okay. So what we are doing in line number 6, we try to do measurement in first qubit. So first qubit, you will get only 0. Okay. So what is the value of our 0? Okay. 1, 0. Okay, 0. So instead of this, if you are giving 0 over here, what happens? Exactly. So change here, put 0, try to measure and execute your circuit. Now you got 0, 1. So I will explain. Okay, we have Q0 and we have Q1. So what we did, we implemented NOT gate in 0. 0 means Q0. Okay, so everything will start from stage 0. So stage 0, here we have stage 0. Okay, because of NOT gate, we will get state 1 over here. Okay, so what we are doing, measurement probability over here. So if you are measuring this, what we will get? Binary value 1. So how we are representing binary value? So we are representing with 0, 1. So state 1. So if you are running any code, try to change this parameter and observe what happens. So if we implemented NOT gate in 0, okay, instead of qubit 0, we are measuring 1, you'll get the reverse process. Because now the circuit contains 0 in qubit 2. You try to measure qubit in 2. So that is why you got 1 0. You should be always careful what gate you implemented in which qubit and where you are measuring, where you are seeking your probability. Is it clear? Are you able to follow? Okay. So go to your Penny Lane website. Go to your Penny Lane website. So if you want to explore some demos, you can click explore demos. Okay. So you can have variety of application. You have demos based upon paper. Suppose if you are starting some research, you need to have some base paper. So everything will get in this repository. Okay. So somebody asked, we can do max cut problem, hidden cut problem. So everything is over here. Okay. So if you are involved with chemistry, coding is here, supervised learning, unsupervised learning, all demos are there. Okay. It will consume your time. Okay. Initially go through fundamentals, learn one by one, slowly, try to change value, understand fully, then proceed for subsequent topics. Okay. So tensor network also there. Okay. Hamiltonian is also there. Right. If you are involved with optimization, you can find 37 different types of demos. Okay. So if you click any topic, so all these topics are a little bit complex for you because you need to understand all quantum process. Otherwise, you cannot digest. Okay. So they gave sample coding, but you need to understand the problem domain and you need to know quantum. Then only you are able to understand these definitions. So everything is there. So this is very good website and resource for the researchers if they want to do chart. Okay. So they give step-by-step guidance. Then you can optimize according to your need. So Penny Lane is not about simulation and execution. What is interesting about Penny Lane, they gave quantum data sets. Suppose if you want to do quantum machine learning, you need to do over quantum data set. So quantum data set available across the internet is very, very limited. So I'll share this link so you can save for your research in future. So bookmark this link. So this is very good repository to collect quantum data set. Okay, so what is the good thing? Suppose if you are working on some quantum project, you are able to convert classical data into quantum data, then you can add that data set repository over here, like community contribution. Okay, multiple ways you can use this platform, not only as the user, as also like a developer. So go to documentation. Suppose if you want to understand in depth, you can start from here, quantum circuit. Okay, so they gave sample code. You can define devices. They gave step by step, right? So slowly you are able to produce output in this way. So somebody asked how to visualize your output. You can visualize your circuit in this way. So whatever we discussed in this 2 hour, you able to implement over here. I'll share this link also. So that's all about today's session. So if you have any doubt or interesting question, you can ask me. Thank you all for patiently listening until this. So if you joined late, please try to rewatch this video. Follow this step, very easy. Make sure you use Google Colab. Otherwise, you can use Cubraid also. You can install in your Jupyter notebook. Thank you all. Thank you.
Uh, Thank you, sir. I think all the questions here have been already covered. So, participants, if you have any questions, just quickly put that in the chat box. It seems they have the questions. Sir, I think there is one question.
Any simple book or notes, you follow that website. A website contain each and everything in very simple way. So you need to check all these links. Okay. Try to copy code one by one, line by line. Try to execute. Simple. Already the code is very simple. Just I covered 20 lines of code. So having length of code is not important. Whenever you have small code, try to change parameters. Try to understand how it works. That is more important.
Right, sir. I think one more question somebody asked: how many qubits currently available on PennyLane?
It is simulation, right? A simulation,
Yeah.
you can go for 30 or 50. Beyond that, simulation won't do anything impactful. Only the real quantum execution will do. Okay.
I think in simulation we'll not get the speed up, no, sir?
Real result. Real
Yeah.
result we won't get. Cube is free, but if you have money, you can go for premium version. So all these company, what they will do, they will give free platform for sometimes, then they try to charge. Until demand is there, they will give for free.
Right. So hopefully they are giving for free to create the demand. Once the demand is already created, they will probably not offer this for free. They will charge it somehow. So I think
Because
till the
that is how business model works.
right, sir. So it's like till the time all the things are free, you should take as much as possible benefit of those methods and or those platforms. So
Exactly.
I think there is no other questions. So yeah, so let's then wrap up for today. So thank you very much, sir, for all this hands-on and all these tools that they were probably going to use at some point of time. I mean, anyone who is trying to work in quantum will have to use one tool or another at one point of time. Without that, there is no escape. You cannot just do it on mathematics and publish anything. So yeah, these 3 4 lectures are very important. Kindly go back to the YouTube, as I said yesterday also, and try and ask that. We'll have sir once again on Monday for 1 hour in the morning, in the 3 to 4 the first slot, and then we'll have Janani ma'am on the second slot on Monday. But if you still have any question in Jaikumar sir's sessions, you can prepare the question, get back on the Monday. We have search session from 3 to 4. Prepare the question, keep it with you, and if you have any doubts, you can ask sir when we'll be interacting over there. So I think that's all from our side. Thank you once again, sir. for delivering such an impactful session from the last few days. And we'll have you on Monday once again, sir. Meet you on Monday once again.
Thank you, sir. Thank you all.
Thank you. And participants, once again, I will remind you that the quiz are open. Kindly take on the quiz by Monday. And again, as I said earlier, you will have a single shot on that. So first prepare for the quiz, then try to attempt. Otherwise, I have seen in Q1 some people have faced problem on that. So please first prepare on the syllabus, then you attempt. You will get only 30 minutes to attempt the question. So please do not just open it and close it. That will be considered as already attempted. So please do not do that. In a single shot, you will have to do it. Right. So with that, let's wrap up for today. Right. And we'll meet once again on Monday afternoon, 3 p.m. Happy weekend and happy uh, quiz 2 to all of you. So thank you. Thank you all. See you on